Hello friends, today we are going to talk about the serial communication using 8251. So before starting with the topic, let me tell you what exactly the serial communication is. So here, as the name indicates, serial refers to one bit at a time. So when we talk about the serial communication, we encounter with the terms like parallel to serial conversion and serial to parallel conversion. So let us see what are these things. So the first one comes parallel to serial conversion. So whenever there is a transfer of data from the microprocessor to the peripheral devices, as I am showing here with the help of a diagram, an 8-bit parallel word will be converted into a stream of 8 serial bits, and this conversion of 8-bit parallel word into the stream of 8 serial bits, we call it as parallel to serial conversion. And since here only one bit at a time is transmitted over a single line, it is given a rate called baud. Okay, and this baud rate, in other words, we can define it as bits per second. Okay, that means the number of bits transferred per second is called as baud rate. The next term what we are going to encounter is serial to parallel conversion. Here, whenever the microprocessor is going to receive a stream of 8 bits, as here I am showing with the help of a diagram, these serial bits should be converted into 8-bit parallel word, and this conversion of 8-bit serial stream into the parallel word, that is 8-bit parallel word, we call it as serial to parallel conversion. So now let us start with the basic concept of serial I/O. Okay, so let us see here what are the basic concepts involved with the serial I/O. So we are having the first concept is interfacing requirements. Then we are having alphanumeric codes, transmission format, error checks in data communication over telephone lines, standard in serial I/O, and finally software versus programmable hardware approaches. So now let us start and see in detail what are these concepts, starting with the first one called interfacing requirements. So here, by using this diagram wherein I am going to show the serial input output interfacing, here the microprocessor is going to identify the peripheral by using the port address, which is enabled either by using read or write control signal. So overall we can say the microprocessor is going to select the peripheral by using the chip select. Already we know what exactly the chip select is, and it is using the control signal read to receive the data and write to transmit the data. Okay, and the address decoding, what the microprocessor is doing, it can be either peripheral I/O or the memory mapped I/O. Okay, and here one more point what we should keep in mind is that the serial peripheral can be interfaced. This one, it can be interfaced under either the program control, which is nothing but the status check, or interrupt control. The second one comes in the form of alphanumeric codes. So the most commonly used code for serial communication is ASCII code, which is 7-bit code. Okay, and this 7-bit code with 2 or 128 combinations is assigned to the letters, decimal numbers, symbols or machine commands. Okay, so here I have tried to show you the ASCII codes what we are going to use, like numeral 0 to 9 we are going to show with the help of 30 hex code to 39 hex code. So this is the range which is going to show you the numerals 0 to 9. Similarly, we are allowed to show the uppercase letters, various symbols and machine commands. The third basic concept, which is the transmission format, let us see. So when we talk about the transmission format, As we know, it is basically concerned with the issues like synchronization, the direction of the data flow, the speed, the error, and the medium of transmission. So here let us focus with the two different type of transmissions. The one is synchronous transmission and another one is asynchronous transmission. So here when we talk about this synchronous transmission or synchronous format, as you can see here, where the transmitter and receiver we have synced. Okay, that means these two, the receiver and the transmitter are synchronized, and we are going to transmit a block of characters along with the synchronized information. Okay, and this type of transmission we are using particularly for high speed data transfer or high speed data transmission. Whereas when we talk about the asynchronous transmission, here as you can see, it is a character oriented. Please do remember, asynchronous transmission refers to the character oriented. Okay, here each character is going to carry the information about the start bit and the stop bit, and when there is no data being transferred, then the receiver is going to stay at the high, that means at logic 1, which is called as mark, and the logic 0 is called as space. Okay, so here as you can see with the help of diagram, the transmission begins with one start bit, and this start bit should be always low. Okay, it is followed by the character. Character can be an ASCII character which is of 8 bit, followed by 1 or 2 stop bits which is known as framing. So totally in the asynchronous transmission, if you wanted to transmit 1 bit, that means totally 11 bits we are going to transmit. Okay, and one more point I missed out here, in the whenever you are using asynchronous format, that means we are using low speed transmission format. Now let us see what are the different transmission formats available when we talk about serial communication. So generally the transmission format can be divided into two formats. One is synchronous and another one is asynchronous. Let us see. So here it is. As I have told you, transmission format can be either synchronous or asynchronous. So when we talk about the synchronous format, here the receiver and transmitters are synchronized, and the block of characters can be transmitted at a time. And we are using this synchronous format particularly when we are having high speed transmission. The other type of transmission format is asynchronous format, which is character oriented. That means here we are going to transmit one character at a time, and each bit or each character is going to carry the information for the start bit and the stop bit. Here please do remember, we are having one start bit and 1 or 2 stop bits. But when we are not transmitting any data, then the receiver is going to stay at high, that means at logic 1, which is called as mark, and logic 0 is called as space. Okay, so in the asynchronous format, remember that transmission is beginning with one start bit which is low, followed by the character what you wanted to transmit in the form of ASCII format, and 1 or 2 stop bits which will be high. Okay, so this entire group is called as framing. Okay, so framing is nothing but combination of one start bit, the character which you wanted to transmit, followed by 1 or 2 stop bit. Okay, and this asynchronous format particularly we are using in low speed transition. Now after seeing the different transmission format, now let us focus on the transmission modes also. So we are basically, when we talk about this transmission mode, we can divide this transmission mode into the first one as simplex, and The second one as duplex. Simplex or simple transmission is the transmission where the data is transmitted in only one direction. Okay. For example, the transmission from microcomputer to the printer, or it can be anything wherein the data is transmitted in one direction only. Okay. And the second type of transmission is duplex. This, as the name indicates here, the data transmission is in both the direction. That means the flow of data will be in both the directions. Okay. So this duplex can be further subdivided into, first one is half duplex and second one is full duplex. As far as the half duplex is concerned, that means if the transmission is one way at a time, then we call it as half duplex. The example of half duplex can be walkie-talkie, wherein though it is a two-way communication, we can transmit the data one way at a time only. Either you can talk on the walkie-talkie or you can just receive the data. Okay. And the second type of duplex is full duplex, wherein the data transfer is possible in both the ways simultaneously. Okay. Like the data transmission between two computers or over the phone, as you can call your friend and you can talk over the phone. It will be the example of full duplex. Yeah, one more point I have missed here. The example of the simplex transmission mode can be radio, wherein the data transmission is in one direction only. Like when you are listening to music or some other program onto the radio, it is one-way communication. You are not allowed to communicate back to the radio station. Okay? Error checks in data communication. So whenever we are transmitting the data, there are different type of errors which can occur. Like there can be data bit change due to the noise, or because there is a difference between the transmission and the receiver clock, the data bit can be misunderstood. Okay. So now to check the errors in the data communication during the data transmission, we can have an additional error checking information which can be sent along with the data during the transmission. Okay. So here the receiver is going to check the received data against the error checking information, and if there is a mismatch, that means if an error is detected, then the receiver can request for the retransmission of the data. Okay, so this is what I was talking about. So if we talk about the different type of error checking methods, then we are having the error checking methods like parity check, checksum and cyclic redundancy check. Now let us see how exactly these error checking methods are working. First, starting with the parity check. As we know, this parity check we are using to ensure that there is an accurate data transmission. Okay, so what exactly we are going to do here is we are going to append the parity bit to the original data to create odd or even number of ones. Okay, so in the parity check we are going to have either even parity or the odd parity. So let me try to explain the concept with the help of an example. So here I am assuming that the original data which we wanted to transfer is 101 0001. So this is the original data. Now if I wanted to add the parity bit to this one, okay, so I can use either the concept of odd parity or even parity. Now let us assume in case if I wanted to use even parity. Now here if you count the total number of ones in your data, it is odd number of ones since we are having only 3 ones. Okay, so what we have to do is add one additional 1 to the left side of your original data. Then your data after adding the even parity will become something like this. So now the last bit is nothing but the parity bit or even parity bit. Okay, so when we talk about the odd parity, Okay, that means the total number of ones in the actual data should be odd in number. Now since here in the original data already we have odd number of ones, so the parity bit what we are going to add is 0. So that's why here I have written add 0 to the left hand side of the original data. So if you are going to transmit the odd, use the odd parity, then our output will be something like this, which I am going to transfer instead of this original data. And as we know, it is using to check the error. And in particularly when we talk about the 8085 microprocessor, we are going to use the parity flag. Okay, this parity flag is going to check the parity information in each and every character. Okay, the next type of error checking method is checksum. So this checksum is basically used when we are transferring block of data at a time. So what is the basic idea of this checksum? So the basic idea is same, to check the error or to detect the error in the data communication. Okay, so let us assume the data, and let me try to explain this checksum with the help of an example. So let me consider the set. Okay, so please do remember here we are going to transmit our data in the form of data set. Okay, wherein I am having certain numbers. Okay, now here I am having a set of numbers like 7, 11, 12, 0 and 6, and I wanted to transfer this to the receiver. Okay, so here what happens is I am going to, instead of sending these bits, I am going to send the bit like this. Okay, wherein I am sending the bits like 7, 11, 12, 0, 6 and 36. This 36 is the sum of the original data. If you add the set of numbers like 7 plus 11 plus 12 plus 0 plus 6, you are going to get 36. So instead of sending the original set, I am going to set this particular set of data, wherein I am having one more additional bit called, which is the sum of the actual data. And when we are going to transmit it at the receiver side, the receiver is going to compare the result with the sum. Okay, the person is going to compare this result with the whatever sum it is. Okay, if it is same, then the receiver is going to assume that there is no error, and the receiver is going to accept the data whatever we have sent. And if there is a mismatch, okay, then the data whatever has been sent will not be accepted, and we can request the sender to resend the data. Now what exactly is the checksum here? Okay, so as I have told you, if there is an error, we can request the sender to retransmit the data. Okay, and here the job of the receiver, where he is going to compare the data with the sum. Okay, we are going to make the job of the receiver easy. Like instead of sending the sum like 36, I will send the complement, that means the negative of sum. The negative of sum which is sent along with the data set is called as checksum. Okay, this checksum, so by using the checksum, if I wanted to send the data, it will be something like this. Okay, so I am going to send the bits like 7, 11, 12, 0, 6 and minus 36. So the receiver, what he or she is going to do is, they are going to add the first 5 bits, okay, check the sum, and when they are adding to the checksum, the remainder should be 0. If it is 0, then it is assumed that there is no error. Okay, and they are going to accept the data whatever has been transmitted. And if there is a mismatch, if there is an output of non-zero number, then we are considering that there is certain kind of error detected, and we can ask the sender to retransmit the data. Okay, this is about the second error checking method called checksum. Hope you have understood. Then the third one comes in the form of cyclic redundancy check. It is also an error detecting code which is used to detect accidental change to the raw data. The data communication over telephone lines. So whenever you wanted to transfer the data over the telephone lines, then we need to have the modulation techniques being used. Okay, so the modulation techniques what we are going to use is either the frequency shift keying, or in short FSK if we are having low speed modems, and phase shift keying or PSK in case you are having high speed modems. Okay, so the modems are the devices which are going to translate digital data into audio tone frequencies for the transmission over the telephone line and convert audio frequencies into digital data for the reception. Okay, so by using this one, the computers can exchange information over the telephone lines by using two modems, one on the each side. So let me show you the same concept with the help of a diagram. So here I am showing the communication over the telephone line by using modems. So as here you can see the microcomputer is there. Whatever the data from the microcomputer is coming out, it is parallel in nature. Okay, so we are having parallel to serial converter, which is going to convert your parallel data into serial form. That means either in the form of 0 or 1. That means we are going to transfer the data in the form of bits. Okay, so after that we are having a modem. This modem is going to convert the digital data which is in the form of 0 and 1 in the audio tone frequency, so that you can transmit over the telephone line. Okay, and on to the receiver side, if you see, whatever the data is being received is first accepted by the modem. This is going to convert the audio frequencies into digital data. Okay, and that digital data which is serial in nature, we are going to apply it to once again the converter, and we are going to transfer the entire data to the microcomputer. Okay, so this is the concept of data communication over the telephone line. Standards in serial input output. So the term standard refers to the features which are generally accepted in the industry, and these standards are normally defined by the professional organizations, and the standards can include assignment of the pin position, voltage levels, the speed of data transfer, the length of the cable, and the mechanical specifications. And the serial I/O is basically used to interface terminals, printers, and modems. So when we talk about the serial I/O, the data can be transmitted in the form of either current or the voltage. Okay, so particularly when we are transmitting the data in the form of voltage, we are using the standard called RS232C, and it is defined in reference to the data terminal equipment and data communication equipment. So before seeing the concept of data terminal equipment and data communication equipment, let me tell you the rate of data transfer in the RS232C is restricted to maximum of 20 K band, and it can be transferred up to the distance of 50 feet. So let us come to the point where we are going to discuss about the DTE and DCE. As far as the DTE is concerned, if you focus here, we are using the term called terminal. Terminal refers to the end equipment. Okay, so terminal can be any end equipment like computers, printers, and so on. Okay, so here the end instrument can convert user information signal. Okay, and as the name indicates, it is the terminal equipment, where that means it is a device where the communication is going to end. The second one is data communication equipment. This is the equipment which we are going to place between the data terminal equipment and the data transmission circuit. And we are using this DCE to perform this the function of signal conversion. That means it is going to provide the path for the communication purpose. So let us see. Let us consider there are two terminal equipments A and B. I am considering it to be the computers. Then if they wanted to transfer the data, if there is a data transmission between A and B through certain medium, like for example WAN I am using, this is wide area network, by using which A and B are going to transfer the data. Okay, so there can be the transfer of data through the WAN. Okay, now here the DCE or data communication equipment, as we know, it is going to perform the function of signal conversion. Okay, that means parallel to serial and serial to parallel is placed between the DTE and the communication or the data transmission circuit. That means between A, B as well as the WAN. So I am going to place these DCE equipments, which is nothing but the data communication equipments, which are going to function as the signal converter. So the example of this DCE can be modem. So this is the way in which there will be the data transfer whenever we are transferring the data in the form of voltage. And when we talk about the RS232C signals, okay, so we can divide the signals into four groups. Like we are having the data signal, we are having control signals, the timing signals as well as the ground. As far as the data signals are concerned, we are going to use the voltage level of +3 to +15 volt for logic 0 and -3 volt to -15 volt for logic 1. Okay, and the logic circuit what we are going to use here will be TTL. So here I have given certain points like the minimum interface between the computer and the peripheral will require 3 lines, particularly pin number 2, 3 and 7. And whenever the DTE, that is data terminal equipment, wanted to transmit the data, it should use the pin number 2, and whenever it wanted to receive the data, it should happen from pin number 3. Whereas when we talk about the DCE, that is data communication terminal equipment, it is going to transmit the data from pin number 3 and receive the data from pin number 2. Let us understand this one with the help of an example. So here I'm showing you the RS232C connection. Okay, if you see the first diagram here, you can see that there is a data communication between the data terminal equipment as well as the DCE, which is nothing but the data communication equipment. Okay, so there is a data transfer between the computer as well as the modem. So as we know, the DTE is going to use pin number 2 for transferring the data. So here I am using arrow towards DCE. TX indicates transfer of the data, and RX, which is nothing but the DC is as it is receiving the data. So I have written here RX, and DCE is going to receive the data from pin number 2. Similarly, DCE is going to transmit the data from pin number 3 and DTE is going to receive the data from pin number 3. Whereas pin number 7 in both the devices will act as the ground. Okay, when you go for this second diagram wherein I am showing you DTE to DTE communication, that means data terminal equipment to data terminal equipment communication. That means the communication between two end terminal. End terminal can, as I have told you, it can be either printer or the computer and so on. So here I am going to show you the communication between computer and the printer. As we know, pin number 2 is for transferring the data and pin number 3 is for receiving the data. Now here you can see that the transmitter and receiver lines are crossed over, and this crossing over of the lines is called as null modem connection. Okay, the term null modem connection is nothing but when we are directly connecting two DTEs, that is N terminals, using RS-232, we are going to call it as null modem connection. Okay, hope you have understood this one. Thank you.